Very good evening, all of you. Today we will be discussing a very important topic, that is climate change. Climate change. Right. So first we shall start with the definition of climate. What is climate? So climate is nothing but we can call average weather. Climate is nothing but average weather. Now there are some attributes of weather you might have studied in geography. Some attributes of weather. Some attributes of weather. Attributes like temperature, atmospheric pressure, wind, precipitation, etc. Right, so there are many of them. Some of them are temperature, pressure, atmospheric pressure, wind, precipitation, etc. Out of which, when we talk about climate change, temperature becomes very important. So average weather is climate. But what do you mean by average? Of how many years the average you will take, right? So average can be of decades to hundreds to thousands to millions of years, right? To millions of years. So average can be varied, right? Average can be from decade to hundred to thousands to million of years. But as per WMO, that is World Meteorological Organization, the average of 30 years, and in present context it is taken from 1981 to 2010. As per WMO, this average temperature is 14.3 degree Celsius. Average temperature of this 30 years is 14.3 degrees Celsius. And when we talk about average rise or increased global average temperature, so from this will be our reference point, 1981 to 2010. So 1981 to 2010, the average temperature is 14.3 degrees Celsius. And when we talk about present global average temperature, it is 0.45 degrees Celsius to 0.5 degrees Celsius. This is the range. 0.5 degrees Celsius rise in temperature has taken place. So from which data we are comparing, right? Global temperature is increasing. From where it is increasing? For example, when we talk about GDP increase, so we compare it from some base year. So this will be our base year here. 1981 to 2010 is our these 30 years, the average global temperature was 14.3 degrees Celsius, and then we can see the rise in this temperature by 0.45 to 0.5 degree Celsius, right? So when we talk about average weather, so weather is this, and what is average? So average can be anything, but we are taking as per one example I have given you, as per WMO, this is the, but we can also take one more example. Before that, WMO says two things. WMO says this climate change. Sometimes climate variability can also be misinterpreted as climate change. So what is climate variability? So as per WMO, there are two terms. One is climate variability, and one is climate change. One is climate change. What is climate variability? What is climate variability? It is non-persistent. It is non-persistent abnormalities. Non-persistent abnormalities. For example, short-term, non-persistent abnormalities or short-term abnormalities, right? This will be known as climate variability, not as climate change. But those abnormalities or those abnormalities which are persistent, so persistent abnormalities will be known as climate change, So it is long term, right? It is long term. Just now you have seen we have taken average of 30 years to compare with, right? So the temperature increase. So if it is a climate variability, for example, in 1 month or some 1 day or 2 day or 3 days, temperature is higher, then it will not be attributed to climate change. Rather, it will be attributed to climate variability. But when it is a non-persistent, it is long-term change or a long-term variation is there, this long-term variation is known as climate change. But when we talk about IPCC, Intergovernmental Panel on Climate Change, IPCC, Intergovernmental Panel on Climate Change, its Article 1 says, that if climate system change, is influenced or caused by human or anthropogenic factors, or processes, then it is called as, climate change. But if climate system changes due to natural factors or processes, then it is called as, climate variability. Changes due to natural factors or processes, then it is climate variability. So since this climate change or climate variability, right? So since these areas are still evolving in nature, research are still going on, and we are not having a universally acceptance terms and definitions apart from the traditional terms. So we are having different ideas with respect to what is climate variability and climate change. So we have seen two definitions, as per WMO also and as per IPCC. What is climate system change? What is climate system then? What is climate system? So WMO, when IPCC says that climate change is about, when IPCC says that climate system is changing, right? And if climate system is changing due to anthropogenic factors, then it is known as climate change. And if climate system is changing due to natural factors, then it is known as climate variability. So what is climate system? So as per IPCC, we are talking about climate system components. What are these climate system components? Number one, this is lithosphere. So everything related to rock, right? earth, right? Lithosphere. Second, related to water, hydrosphere. Third is atmosphere. And fourth is cryosphere. And where life exists, biosphere. So these are the climate system components. Climate change impacts on these things, right? Lithosphere, hydrosphere, atmosphere, cryosphere, and biosphere, where the thin part of earth where life exists, that is biosphere, right? So as per IPCC definition, these are climate system components and climate change and climate variability. So these are two terms which are being used in the discussions. Now come to the indicators of climate change. Indicators of climate change. Indicators of climate change. How do we know that climate is changing, or what are the evidences that climate is changing? Indicators of climate change. Number one, the most discussed term, that is global warming. What is global warming? The average rise in the temperature. What is global warming? Is average rise of the temperature. Now see, global warming, that is average global temperature is rising. Average global temperature is rising. Average global temperature is rising, that is global warming. And as per IPCC, if we compare from the data of 1880, if we compare the data from 1880, means from 1880, the average temperature has been increased by, the global average temperature has been increased by 0.85 degree Celsius. The global average temperature has been increased by 0.85 degree Celsius. So the global average temperature is increasing. This is known as global warming. Right? Second indicator, if we talk about, sea level is rising. Sea level is rising. What do we mean by sea level is rising? If we compare a data from 1901 to 2010, if we compare data from as per IPCC, if we compare from the data of 1901 to global temperature is sea level is rising. Average global sea level is rising. Then if we compare data from 1901 to 2010, then the average sea level, global average sea level has been increased by 0.19 meters. 0.19 meters. This global average temperature, global sea level has been increased by 0.19 meters. And what do we understand from this? If global sea level is increasing, then small island developing countries, SIDCs, small island developing countries, for example, Tonga is there, Tuvalu is there, Fiji is there, Fiji. These countries are facing lot of problems with respect to global sea level rise. right? Because these what will happen with respect to these countries? These are small nations and small island nations. These are surrounded by oceans, and when global average sea level is rising, these are small island countries, and since they are developing nations, so they don't have much capacity or capabilities to fight with this change, and these countries are facing lot many issues with respect to this, right? So this is sea level is rising. This was the second indicator that we saw. We can see another uh, some other things also, like early ripening of early ripening of crops, ripening of crops, or uh, early maturing of crops, ripening of crops or fruits, early ripening of crops or fruits. This is also one indicator of climate change. We can also have a look on increased rate of increased rate of thawing of permafrost, thawing of permafrost, permafrost. What do you mean by thawing? Thawing is nothing but melting. And what do we mean by permafrost? Permafrost is nothing but uh, the ground which is at sub-zero temperature, sub-zero temperature, sub-zero temperature for continuous 2 years, at least 2 years, continuous 2 years, continuous 2 years, thawing of permafrost. So increased rate of thawing of permafrost. Now it is melting of this sub-zero temperature for continuous two. The ground at which the temperature is sub-zero level means completely frozen ground, also called as also known as completely frozen ground, completely frozen ground, right? So this thawing of permafrost is natural process. It is a natural process. Then if it is a natural process, then what is the issue here? If it is a natural process, then what is the problem? The problem is, since it though it is a natural process, but the thing is, due to human interventions or due to human activities, due to human activities, the rate of thawing of permafrost, the rate has been increased. The rate has been increased. The rate has been increased. And this is also contributing in climate change or global warming. How? Because this thawing of permafrost, they release carbon dioxide and methane. They release carbon dioxide and methane, right? So thawing of permafrost is contributing in global warming, and it is how they are it is contributing in global warming. Release of CO2 and CH4 methane, though both are global warming greenhouse gases. Both are greenhouse gases. We will have a discussion on greenhouse gases in just a minute, right? So in the future proceedings we will discuss greenhouse gases. Now coming back to the point that due to human activities the rate has been increased. Thawing of permafrost rate has been increased. If we consider one report, as per one report, if we talk about the frozen waste of Arctic and nearby areas, the frozen waste of Arctic and nearby areas, they have they hold CH4 and CO2 holds CH4, that is methane, and CO2, that is carbon dioxide, equivalent to anthropogenic emission of these gases for 15 years. For 15 years at present level. At present level. So at present level, whatever we are at present level, whatever we are emitting, CH4 and CO2, this thawing of permafrost is holding 15 years of emission of CO2 and CH4. So if it is released suddenly, then it is equivalent to 15 years of CO2 and CH4 emissions. So this is the role of permafrost, right? So this is one of the indicator thawing of permafrost. One more indicator if we can talk about, that is extreme weather events. It is number 4. Sorry, number 4. Number 4 is number 5. Extreme weather events. Extreme weather events like drought and floods. Drought and floods. Extreme weather events. One thing also we can say about it, that increase in tropical cyclones. Increase in tropical cyclones, right? So this is also one factor. One more thing we can talk about, that is we will discuss in the subsequent classes, that is ocean acidification. Ocean acidification. The process of ocean becoming acid, ocean water becoming acid. But right now it is not acidic, right now it is basic only, but its pH level has been decreased from 8.2 to 8.1. So its pH level is decreasing, right, towards acidic. So right now it is basic, because 7 is neutral, right? On pH scale 7 is neutral, and below 7 it is acidic, and above 7 it is basic. So right now it is basic, 8.2 to 8.1. But since ocean acidification is increasing, right, is happening, so its pH level may decrease in upcoming years in future. So this ocean water maybe it can be converted into acidic, right? And that will be a bigger problem with respect to biodiversity, etc., everything, right? So this is ocean acidification. I hope we are clear till here. So we have discussed what is climate change, what is average weather, and what are the attributes of weather, what is what is average basically, and how WMO considers the average, how IPCC considers the average, right? So then we discussed the climate system, right? Climate system components, lithosphere, atmosphere, etc. And then we discussed the indicators of climate change. Now we are coming to the factors of climate change. Factors of climate change. Factors of climate change. So there are natural factors also, there are anthropogenic factors also. Natural factors as well as anthropogenic. We will talk about anthropogenic factors later. We have to discuss anthropogenic factors only, but some natural factors are also there. So some natural factors. Number 1 is Milankovitch cycle. Milankovitch cycle. Milankovitch cycle. Schwab cycle. Schwab cycle. Volcanic eruption. Volcanic eruption. Aerosols. Volcanic eruption, aerosols, and plate tectonic. One more is there. Plate tectonics activities. Plate tectonics activities. Right? Convergence of plates and a divergence of plates that you might have studied in physical geography. Convergence and convergence of plates and tectonic plates and the separation of or the divergence of tectonic plates. One more is there with respect to this aerosols and asteroid and meteoroid fall. Asteroid and meteoroids fall. So these three, when we talk about volcanic eruptions, aerosols and asteroid and meteoroid fall, they basically overall they contribute in cooling. They contribute in cooling, cloud formation and then reflection of coming sunlight. So we will discuss that, but overall they contribute in global cooling, right? So since we are talking about climate change, so cooling is also part of it. So volcanic eruption, aerosol and this asteroid and meteoroid falling, they contribute in global cooling. But when we talk about Milankovitch and Schwab cycle and this plate tectonic theory, see, this is sun and this is earth, for example, right? So Milankovitch cycle talks about earth, the cycle of earth, how earth is revolving, right? So how it is contributing in climate change. So if we talk about earth, then it is given by Milankovitch cycle. And when we talk about sun, the sunspot cycle, etc., then it is given by Schwab cycle. First, we will discuss Milankovitch cycle. First, we will discuss Milankovitch cycle. Now, this Milankovitch, he is a Siberian scientist. Siberian